Hello and welcome to the fourth lesson in the module 8. This lesson is about normal distributions and this is the last lesson in this module. Normal distributions is a very important topic because most of the real life data, when graphed, will have this normal distribution, provided it's a huge number of data. I mean, for a small set of values, it won't get it. Now, imagine you're taking all the students of the school and their percentage of marks, if you have taken it, and then there will be a graph which will be something like this, like a bell-shaped curve. That would be something called normal distribution. What it basically means is very simple. Average, there'll be an average, that's the mean value, okay? This is the middle point. So most of the percentage of the people, majority of the people will be just below average or just above average. Now you might find in the day-to-day life, most of the things will be average. Some things just above average, some below average, just a little bit. But there'll be some who are very, very, very below average. They fall very far away from the mean, or some things which is very above expectations, very high right of average, very far away from average in the positive side. So this is the thing. If there are a large number of data, when you plot it, it generally always assumes a normal curve. Now we will look into the learning objectives. They are to classify variables and analyze probability distributions to determine expected outcome, to analyze normally distributed variables by using empirical rule, and to analyze standard data distribution by using z-values. This is another important one. We will look into all these objectives, and the keywords are probability distributions, discrete random variable, continuous random variable, outcome, sample space, normal distribution, and z-value, and standard normal distribution. Plenty of words. We will try to go through them one by one as we come across them. Now we will look into the first one, probability distribution. Now, mapping probabilities is simply put as probability distribution. Now imagine there's a certain experiment done and you map them in a graph, maybe bar graph. That is probability distribution. Okay? Now, about the outcome, it's basically a result of an event that has happened. Now, imagine you tossed a coin. The outcome is either a head or a tail. Now, sample space would be all possible outcomes. Now, imagine you're tossing a coin. It can be either head or a tail. Now, imagine you tossed and you got a head. Okay, that would be the outcome. But the sample space is both the possibility, one and two, head and tail. Now, if you're rolling a die, there are fair die is six numbers: 1, 2, 3, 4, 5, 6. The sample space is all the possibilities that can happen: 1, 2, 3, 4, 5, 6. But outcome is what that actually happens. Now, imagine you threw a dice and 4 came. That is the outcome. Look over here. Probability distributions can be two different types. One is discrete random variable and one more is continuous random variable. What's the difference between these two? Discrete, as you can see, is specified values, mainly whole numbers, countables. Whereas the continuous random variable can be any number. It can be a decimal point. Look over here. It can be 18, 18.1, 18.05, 18.0999, or 17, 17 point something. All possibilities. So this is the difference between discrete and continuous. Here in this probability distribution, this is basically a probability distribution. You must always know that when you add up the entire probabilities, it must be 1, because what is the probability of something happening? Imagine there is 30% chance that it will rain tomorrow. 30% out of 100, the 70% it's not going to happen. So if you add up both of it, it's going to be 100 or 1. Most important thing to remember, whenever you add all the probabilities, it's going to be 1. Imagine the sample space, heads and tails, 50-50. When you add up, it's going to be 1. There will be something happening, okay? But when you add up all the probabilities, it's going to be 1. So that is important. And the sum of probabilities of x value must equal 1. Yes, obviously, when you add all of these, it will be 1. And now we will look into discrete and continuous. Let's look at the difference. Now imagine you are checking the number of songs on a random selection of smartphone. Now you're looking for a song list. Is that countable? What I would like to think of it as, is it a whole number? It's like one, two, three, four. Yes, it's countable. It's a whole number. It is discrete. You can use the first graph for this. It's discrete. Okay? Because it's countable. Whereas the A pressure and random selection of basketballs, the average A pressure, there might be a certain set of pressure, but it may not be exact. It can be like 5.5 or any sort of pressure. Now, for example, if you know the tires of the car, you might have observed you or someone else filling in the air for the car tires. Now, the set pressure is supposed to be, it ranges from 30 to 34, some 36, even more. But it may not be exactly 36. It can be 36.1, 0.05, or something like that. It cannot be a discrete value. It's basically continuous, A pressures and such things like that. Okay. So here you can see the A pressure of sand basketball can be anywhere between 7.5 to 8.5. It can be any of this value. You can't exactly specify it's going to be 7, 8, 9. It's not like that. That's why it's continuous over here. And let's look at these. Classify each random variable as discrete or continuous. 200 meters swim times. Now, swimming times, it can be literally any time, right? It can be 7.5 seconds, 10.2 seconds. It can be various different values. So it's obviously a continuous one. Number of students in class. You can't have, it's countable. You can't have like zero point 0.5 or something. It's always a whole number. So it is discrete. First one is continuous. This is discrete. Individual archery scores. Now, I checked about archery scores. It usually comes as a whole number, and individual, a single person's archery score can be counted. So it is discrete. The amount of water in a bottle, it can be few ml, point, decimal point, anything, right? It's continuous. Looking at understanding this scenario is important. Then you can easily understand whether it's discrete or continuous. That's the first part. Now we need to analyze probability distributions here. Marketing. A candy company has a promotion in which 4,000 of their candy wrappers won the purchases a cash prize. The frequency table shows the number of winning wrappers for each. So this is the frequency of winning. Construct a relative frequency table and graph the probability distribution. Now, what happens over here is the prices of 5, 10, 20, 30, 20, 50 different prices are there in this candy. This candy company has, put it randomly, these prices in certain candies. Now, if you're very lucky, if you purchase one or some of the candies, you might have a chance to win $2,500 as well. Whereas you have a very high probability to win $5 because there are total 1,250 winners for $5. Whereas 2,500 is only 4. So you can see the difference. But now, what is the total number of winners, the frequency? That is 4,000. They are mentioned over here, or you can just add them up. Okay, 1, 2, 3, 4. Yeah, it'll be 4,000. Okay, because 2080. Yeah. So this is total 4,000. Now the frequency table, what you do is you add up all this, but they have mentioned it. You can use this. Just divide each value of this frequency divided by 4,000. 1,000 divided by 4,000. So you basically do that everywhere. For 1,250 divided by 4,000. 1,000 divided by 4,000. It's how much? 1,000 by 4,000. It is 1 by 4. But now remember, it's all, this will be above. The most important thing what you must remember is not 4,000 divided by this. No, that would be wrong. It is this frequency divided by the total number of winnings. And that's how you get the relative frequency table. Now this is what you need to graph. Basically, you graph this as a bar graph or anything. Look here, 0.3, 0.25. So what you do is, these winning prizes needs to be graphed accordingly. I mean, it should be marked accordingly on x-axis. 5, 10, 20, 50. That's what they have done. And how many people, what is the probability of winning 5? It is 0.31. So you can see it's 0.31. Now, what about 10? That is 0.25. It's over here. What about this 4? See, $2,500. It's very, very little. It's 0.001. This is the thing. Now, what if you add all these relative frequencies? That will add up to 1, the number 1. You can try this, add them all up, your answer will be 1. This is how you basically graph this probability distribution thing. And now then, sometimes, now this was an accurate one, it's properly graphed, but there might be misleading distributions such as this. Let's see this. About salary, a business publishes a report saying that most of its employees earn at least $40,000 annually. When asked to show the distribution of salaries, they provide a probability distribution. Identify any flaws in the representation of the probability distribution. You can see these are the amount of salaries. It's less than 10,000. All these, this part, there is about 15, 16. This is 16, so it's about 15.5, 0.15 a person. 0.15 probability. Now 10 to 20 is almost 17, 0.17. Here you can see 20 to 30 is over here. Then 40 to 50. They told at least 40. That means more than 40. You can see 40 to 50 is over here. And then over here, greater than 70. There is no one with 50 to 60 and 60 to 70. This is the probability distribution now here. What do you understand from this? First of all, look at this scale here, probability distribution. They have zoomed in. They just want to make you look that 40,000 is very high, because they have told what they most of its employees are earning 40,000, which is really wrong. Why? Because there is a huge variation. So many get less than 10,000. This, and these are very, very close, because look at the y-axis. 0.15, 0.17, 0.1. It's so little difference. They have just zoomed in this value. That's the reason. Now, if you see over here, 0.1, 2, 3 gives a better understanding. If you had done 0.1, 0, 0.1, 0.2, 0.3, these all would look so similar, you know. So this is one very wrong thing. And look over here, less than 10,000, greater than 70,000. Now, if you have, say, 100,000 salary, 150,000 salary, then the mean would not come as 40,000. The average would really distort. So what they have done is they have not mentioned exactly where it is. So they've just made greater than 40 to 70,000, which is not accurate as well. So these are the flaws. This is what they are saying as well in technical terms. So that's the thing. First thing is the scale is not proper, and then they have used inequalities and they have not specified all the salaries. So that's about it. That's what it's mentioned here as well. Now then, we will go into normal distribution. This is the most important part in this lesson. Now, over here they have mentioned normal distribution usually works, this occurs as the sample size increases due to the law of large numbers. So if you consider a big, huge number, then normal distribution is very, very handy and it works. And also there is one more important thing. When this large of there is large data, okay, you can use the empirical rule whenever it is similar to a normal distribution. Now, what is this exactly? Few important things. This is like a bell-shaped curve which is symmetrical, and the mean is in the middle. The mean, median, mode, all are equal and they are at the same point, which we'll see now. The curve approaches but never touches x-axis, and the total area of under the curve is 1 to 100%, 1 or 100%. Okay. Now this is the normal distribution. As you can see here, sorry, this is what's happening here. It almost approaches, x-axis, but it doesn't touch. But whatever is under that, this curve is always 100%. Now, if you graph data, now imagine all these students' marks of any particular grade, let's say 11th grade, all the students in UAE, let's graph their marks. You will find most of the students will be on the mean average, like whatever is the mean. Now imagine The mean score in UAE is 80. Okay, 80 out of 100. So majority of the people will be having 80. There will be some people less than, say, we should also find what is the standard deviation. Imagine standard deviation is 5. Okay, this is standard deviation, this is mean standard deviation. Okay, that means, sorry, the majority of the people will be at the mean. That is new. Okay, the symbol over here 80, right? This is 80. Now, if you add one standard deviation, this is going to be 85. And what about if you minus one standard deviation, it's going to be 75. So what it says is 68% of the people would have scored within this range. It makes sense. 70 to 85. If 80 is the mean, add one standard deviation and subtract one standard deviation. Majority, 68% of the people will come under this range. What about one more standard deviation? If you add one more standard deviation, that would be 90, and over here it would be 70. Now, I'm not taking accurate data. The data is misleading over because I have no idea about the accuracy of this. I've just taken two numbers, for example. But now let's see. Mean was 80. Now, if we consider from the interval 70 to 90, you would have 95% of the people in that range. That is what happens if you have a huge set of data, and then if you add still more plus 3 sigma, that is this would be 95 and this would be 65, you would have 99.7 of the data, and then it goes on. So this is very important. So you would get a rough estimate of where someone's marks would be. Now imagine a student got 82 marks, then is above mean, so somewhere over here, that is a good estimate. Okay, that means is greater than about 55% of the people. So this is how we can estimate. Now we will look into some problems on this. Oh, now one more thing, when the set of data is not approximately normal, if it's not normal data like skewed data, for example, then you cannot use this normal distribution. The empirical rule with this percentage cannot be used. Now here you can see, if it's data like this, which is normally distributed or which is not exactly normally distributed but similar to it, then it's okay. But look at this data, it's skewed. It's now over here it's negatively skewed, but it's not so accurate. Why? Because you not about accuracy, sorry, you can't use normal distribution data. Why? Because the mean is somewhere over here, the mean is not over here. Over here, if you use it, would be fairly accurate, but here it would be wrong. So you cannot use it for all the cases unless and until it's normally distributed. Now we have a problem here to approximate data by a normal distribution. Now it's not 100% sure whether all data can be normally distributed. So here the total number of goals scored by each player in soccer team during the season is shown. This is the goals. Create a histogram of the set of data. Determine whether the data can be approximated with a normal distribution. Now this is all the data. What you need to do is basically graph them. Let's use a bar graph. How many scored 0? 0 goals were scored by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's supposed to be 13. Now, frequency is basically that. Okay, wait, it's 14. Actually, it should be 13. 0 goals were scored by 13 number of people. Now, what about 1? Let's see. 1, 2, 3, 4, 5, 6, 7. So you can see 1 is scored by just over 6, and middle of 6 and 7 is 6 and 8 is 7. So this is 7. Now what about other things? 2, just counted 1, 2, 3, 4, 5. It's 5. Now 3 is over here by 2, 5, 8, 9, and 11 is by 1, 1, 1. So the frequency is 1. So is this normally distributed? No, it is not normally distributed. So you cannot use normal distribution over here. Why? Because this data is skewed over here. So this is the reason we cannot use normal distribution. That's the thing. So now we will look into the fifth type of problem using empirical data. Now they have told the normal distribution has a mean of 42 and a standard deviation of 6. Find the range of values that represent the middle 95% of the distribution. Okay. Very important to know the normal distribution graph. They want to know 95%. If you knew by heart from the graph, you need to remember this. One standard deviation minus and plus gives you 68% data. 95% would be represented by addition of two standard deviation or subtraction of two standard deviation. So basically, all you need to do is here, what is the mean? 42, right? This is 42 mean. Mean 42 plus 2 times standard deviation is what? 6. That's given over here. And same thing over here, you must do 42 minus 2 times 6. So it is 2 times 6 is 12, 42 minus 12 is 30. Here it is again 12, but you need to add it, it will be 54. So the intervals are 30 to 54, that's it. The values that represent the middle 95% is from the interval 30 to 54 for this particular mean and the standard deviation. You can see it's 30 and 54. Now there's a B question. What percent of data will be greater than 36%? Sorry, greater than 36. Now you can see, if you look at the again the normal distribution, you can see the mean is 42. That means that is over here. 36 is somewhere less than. Okay, it is less than. So let's see. Let's keep on subtracting this standard deviation from the mean. 46 minus 6 would be 36. That's 46 minus 6 is 36. So this is 36. What percent of data will be greater? Now this is important, not less than. What percent of data will be greater? How many? All this is greater than uh, this all is greater than 36. Now how do you understand how much percentage? Keep adding. We know this much. See the mean, where mean is there, it is how much? Mean to year. It is 50%, right? So we know from mean it is 50%, but there is 34% before mean as well. So even this we need to consider, that is 34%. So all you do is 50 plus 34, you get 84%. So the answer would be 84% is greater than this value of 36. So that's it. You add basically 50 and 30. Sorry. Yeah, it's 34. I thought 36. It's 84%. Yes, that's the correct answer. That's how we do it. Now the standard normal distribution here, that is basically given as the Z value. Now what is the Z value? It basically tells you where your data lies in the normal distribution. Now, we just now saw we had to see this, where was where is this exactly, how, which point, how much data is in front of you and everything, right? Now, the Z value exactly tells you where how much, where your point lies based on the mean and the standard deviation. Okay, how much standard deviation away from the mean. So that gives you a very nice understanding. You should know the x value minus nu, where is its mean, the standard deviation is sigma, and then x is the normally distributed data. If we have these three things, we just use the z value, that is the specific data value to measure. It's a measure of position, represents number of standard deviation that the given data is away from the mean. In the sense, if it is 2, that means it's 2 standard deviations away, and so on. Okay, so now we will just look into a problem. This is a given problem. All you need to remember is this: always this formula will not change. Okay, this will not change. So it can be negative value or positive answer, don't worry, but make sure you write the formula accordingly. It is z equals x comes first minus nu divided by sigma. Now all you do is substitute the values. The x value over here is 24 minus sigma 19 divided by 3.8. Just put this in the calculator and you will get the answer. Here all you need to do is 24 minus 19 divided by 3.8. The answer would be 1.315. 1.32 would be the, okay, 1.3 decimal points nearest 1000, that means 3 decimal points. 57, so it is 1.316. That is the answer. Same thing over here. All you need to do is, you may not be asked only z value, they might ask you the x value. Provided all the data is given, you can easily find any of this. So we know z value is equal to x minus nu divided by sigma. Now all you do is substitute 106.3 minus 88.8 divided by 9.6. That would be the answer. Just do the substitution in the calculator. 106.3 minus 88.8 divided by 9.6, and the answer is 1.823. That's how you solve the z value. And that's the thing about this lesson. It's a very simple and easy lesson. Important thing about normal distribution. So please just try to remember the normal distribution graph and a couple of the formulas, and then it's a very, very easy and straightforward lesson. I hope it is clear. If you have any doubts, please do post them in the comments. I try to get back to you very soon. That's it for now. Take care, guys, and all the best. See you in the next video. Bye bye for now.